Alright, here we have a more complex chain rule. We're trying to find the derivative of the square root sine of x squared. The easiest thing, I think, is to actually rewrite the square root. Anytime you see a square root in a derivative problem, it's probably easier to rewrite it as parentheses to the 1/2, right? So if we have sine x squared, right, all to the 1/2, those are equivalent expressions. And it's a little bit easier because then you can see how to do the derivative of something to the 1/2 by just using the power rule. The next layer would be doing sine, the derivative of that, and then we multiply by that. And then finally the inside is x squared, so the third you have 3 layers to account for. And so the chain rule ends up looking like this, right? So the first one is the parentheses to the 1/2. So we bring down the 1/2. The inside of your chain rule stays intact, so it's still going to be sine of x squared, right? But then you're going to take that to the negative 1/2 power because you're taking 1 away from the power of 1/2. The next thing we do is we address the sine of x squared. The derivative of sine is cosine, right? And the inside of that also stays intact. So the x squared is not affected by this because it's still on the inside of your function. You're doing all compositions when you're doing chain rule. So then finally the last piece is you multiply by the derivative of the inside of the cosine of x squared, and that would just give us 2x. If you want to clean this up, you have a bunch of stuff on top. The 2's would cancel, so you get x times cosine of x squared all on the top. The negative 1/2 would bring this down to the bottom, and so you can rewrite it as sine of x squared all under a square root. But since it's to the negative 1/2 power, we put it in the denominator, right? And that would be your answer.